All right, today's topic 8.2, connecting position, velocity, acceleration, and functions using integrals. So we're back to physics. All right, so particle motion. A particle moves around a horizontal line so that its position at time t is greater than 0, greater than or equal to 0, is given by s of t, or sometimes x of t, velocity v of t, and acceleration a of t. Here's a scenario. Your teacher moves along a straight line at the front of the classroom according to the values in the table below. Time is measured in seconds and x of t is measured in carpet squares. Well, we don't have carpet squares in our room, so we can call it tile squares. Anyways, at 0, it's 2, 1, negative 2, 2 is 0, 3 is 2, and 4 is 18. How far was your teacher's ending position from her starting position from t equals 0 to t equals 4? So if I ended up at 18 and I started at 2, it would be 18 minus 2, which gives us 10 tile squares. So now, what is the distance that your teacher has traveled from 0 to 4? So distance is now, it doesn't matter if you're going forward or backwards, you're still traveling. So do you see, you're going to be at, when you go from 2 to negative 2, you've traveled 4. And then from negative 2 to 0, you've traveled 2. And then from 0 to 2, you've traveled 2. And then from 2 to 18, you've traveled 16. If I add that all up, I get 24 tile squares. All right. So this is going to be a calculator question. So let's put v of t into my y1. All right, so I punched it into my calculator. Make sure your mode is in radians, of course. So the first thing we have to do is find all values of t in the interval from 4 to 7 for which the speed of the particle is 5. So recall that speed is equal to the absolute value of the velocity. All right, so you can, v of t, we're trying to find when the absolute value of v of t is equal to 5. So let's look at our calculator. So the way I did this was, because the absolute value of v of t is 5, I put y2 to be 5 and y3 to be negative 5, and I found the intersection. And so that is when t is 5.621 seconds and 6.520 seconds. Remember, it's always correct to 3 decimal places or more. Write an expression involving an integral that gives the position s of t. Use the expression to find the position of the particle at time t equals 3. So it does give you the value over here that s of 0 is minus 3. So s of t is going to be the starting, which is minus 3, plus from 0 to whatever t is. And I'm going to use a dummy variable of x this time because I don't want to use s or whatever because I'm already using that. So then if I use that, I'm going to find s of 3, and that is equal to minus 3 plus the integral from 0 to 3 of v of x dx. And remember that the v function is already in my calculator. So I'll punch that in, and I get minus 6.2629. Find all times t in the interval from 0 to eta which the particle changes direction. Justify your answer. So the thing you have to realize is the particle changes direction when v of t changes sign. So we need to look on the graph of where it crosses and changes sign from 0 to 8. So I'll give you a second to look on your calculator for that. Make sure when you're looking at your calculator as well that you change your window settings so you can see from 0 to 8. All right, so calculate the x-intercepts. So I'll write what I said there. The particle changes direction when v of t changes sign. So that happens at t equals 2.341 seconds and another time at 6.127 seconds. Those are the two x-intercepts between 0 and 8. Is the speed of the particle increasing or decreasing at time 7? So we need to look at v of 7. So v of 7 is negative 10.912. And v prime of 7, which is also equal to the acceleration at 7, and that is negative 0.561. So they're both negative. So what does that mean? That means the speed is increasing. So therefore, the speed is increasing at time equals 7 seconds because v of 7 and a of 7 are both negative. For fun, if you want to look at the graph of v of t, the absolute value of v of t, which is the speed, all you have to do is go to math, then number, and then there's function number 1 is ABS, which is the absolute value. If you graph the absolute value of y1, and you look at the graph at time 7, the curve is increasing, which also means it's speeding up. So I'll write that down for you. So note, if you look at the graph of the absolute value of v of t at time equals 7, the curve is increasing. So if you look at this page, it kind of does some of the commonly seen particle motion problems. So you should familiarize what's going on here. So for instance, when a particle is at rest, that means the velocity is 0. If it's moving to the right, that means the velocity is greater than 0. Moving to the left, less than 0. So if it asks you certain things, you can look at the chart when you're first doing some of these questions, but at some point in time, you have to know what's going on. So if I ask you, for instance, is the speed of the particle increasing or the particle speeding up, then you would have to know that that means you are looking at if the particle is speeding up, the velocity and the acceleration have the same sign. So they're either both positive or they're both negative. So just things like that. So what I would do is, again, take some time and familiarize yourself with all these different scenarios. Okay, so once you do enough questions, you'll start to familiarize a little bit more. For instance, yeah. Okay, so let's try an actual example, the Space Shot. The Space Shot is an amusement park ride that gently raises riders up a tower and then rapidly bounces them up and down using compressed air. The velocity of the space shot is between 0 and 14, modeled by a piecewise linear function shown below. T is measured in seconds, V is in feet per second. At what times in the interval from 0 to 14, if any, does the space shot change direction? Give a reason for your answer. So if you're not quite sure where you're supposed to be looking for changing direction, you can go back to your chart here that I gave you until you get familiar of what you're supposed to be looking for. But what you're supposed to be looking for is where V of t changes sign. So where V of t changes sign. So that would occur at t equals 6 seconds. It goes from positive to negative, 8 seconds, and 10 seconds. All right. I'm just going to move this up. So at what times in the interval from 0 to 14 is the space shot the highest? How high is the ride at the time? Okay, so anytime that they're looking for stuff like that, this is where we have to test the endpoints as well as any of the critical spots there, which we've already seen that the critical points are 6, 8, and 10. So we're going to do a table of values with our t, and we're going to call it y of t, because that'll be measuring the vertical distance from 0 to t of v of t dt. Okay, so we're going to test 0. 0 goes in there, we get 0. Okay. We're going to do 6 now. So this is the integral from 0 to 6 of v of t dt. So this is the area. You can see here that we have, a rectangle here. It's 5 by 20, which is 100. Sorry, 4. I counted that wrong, didn't I? 4 by 20. And then we have 2 triangles that are exactly in half, so that would add another 20 to that, so we get 100 for that. Then we're going to go 8. So this is from 0 to 8 of v of t. Well, I've already figured out that it's 100. And then the area under the curve means I'm going to subtract. That is a triangle there, so I'm going to subtract 1/2. The base is 2. The height is 60. So that is the 2's cancel. So basically I'm going to get 40 out of that. Again, you can use a oh, this says no calculator, so we're not going to use a calculator. We should be able to do this in our head. Okay, 0 to 10 of v of t dt. So again, we were at 40 up to 8. So then we just have to look at where we are from 8 to 10. And that is a triangle that we're going to add to it. 1/2, the base is 2, and the height is 40. Again, the 2's cancel, so it's just 40 plus 40 gives me 80. And then at the end point at 14, we are from 0 to 14 of v of t dt. So we were at 80, and then it's below the axis, so now we're going to be subtracting. Again, it's a triangle, so 1/2, the base is 1, 2, 3, 4, and the height is 40, so this would be 2. Oh, so it's 80 subtract 80, which gives me 0. So that means the 100 is my highest, so I would say therefore the max height is at 6t equals 6 seconds with 100 feet. All right, so now we're going to find the total distance here. The total distance from 0 to 14. So again, remember the total distance. Don't forget what total distance is. Total distance means it doesn't matter if I'm doing positive or negative, right? So from 0 to 14 of the absolute value of velocity. So this is going to be 100 plus 60 plus 40 plus 80 gives me 280 feet. All right. So now what they want is to write expressions for the ride's acceleration a of t, velocity v of t, and distance s of t from the ground that are valid for the time interval 10 to 20. All right. So a of t, a of t is going to be minus 40 divided by 2 gives me minus 20. My v of t minus 0 is equal to minus 20 t minus 10. So v of t is going to be minus 20t plus 200. And then if I find s of t, again, we keep on going, we're going to be starting at s of 10, plus we're going from 10 to t of minus 20x plus 200 dx. Again, I'm using that as a dummy variable there. By the way, if you're confused of how I got a of t, that's just the slope of the line from 10 to 12 there. So I'm going down 40 over 2. And then from there, I'm using that as my derivative, which is my slope. So then I can use that and go from there. So maybe take some time and look over how I got this and discuss. All right, so now we're going to do example 3, and you're going to choose the expression that you would use to solve each problem. So a particle moves in a straight line with a velocity v of t meters per second, where t is in time in seconds. At time 5, the particle's distance from the starting point was 6 meters. What is the total distance the particle has traveled between t equals 5 and t equals 10? So you got to ask yourself, like, what's going on here? And we're talking about what is the total distance. All right. So I'll give you a couple of minutes or so to figure this out. If you're having trouble as well, you can look at the chart about 3/4 of the way down. It says total distance traveled by a particle over time in interval AB is the integral from A to B of the absolute value of v of t dt. So they're kind of giving you something to think about when they have the starting point of 6 meters. That has nothing to do with right now. So the correct answer would be C. So let's look at number 2. A particle moves in a straight line. V of t equals t squared minus 3t minus 7, where t is in time. At time 2, the particle's distance from the starting point was 10 meters in the positive direction. What is the particle's displacement between 2 and 9? So I'll give you a couple minutes to think about that one. So again, if you look at the chart, if you're having trouble remembering what displacement was, 3/4 of the way down, just below distance, is displacement of the particle is traveled over time a to b is the integral of a to b of v of t dt. So that would be your answer B there. All right. All right, to sum this up, now we use the NUT strategy to interpret motion of integrals. So NUT stands for noun, units, time. And so we're going to talk about the position of a particle moving on the x-axis in feet from the origin is given by x of t. The velocity of the particle in feet per second is given by v of t. The acceleration is given by a of t. For each of the integral expressions given in the following table, interpret its meaning by filling in the missing noun, appropriate units, and or correct time, value, or interval. So the first one is x of 2 plus the integral of 2 to 4 of the derivative of x of t dt. So again, you kind of have to, if you're having trouble with this, look at the chart to get you going. But again, at some point, you're going to have to know this. So this is, the position of the particle. And this is going to be in feet from the origin. And the time is at 4 seconds because it's going to 4. Okay, so the next one is we're going the integral of 1 to 4 of the derivative of x of t. So what is the derivative of the x of t? Well, so this represents the change in position of the particle, and this is going to be in feet, and the time is going from t equals 1 second to t equals 4 seconds. So all we're doing here is interpreting what we're actually calculating here. So if we have 1 over 4 minus 1 of the integral of 1 to 4 of the absolute value of v of t, so the absolute value of v of t, of course, is speed. What are we doing before the integral? That is calculating the average speed of the particle. And that would be in feet per second, and this is from t equals 1 second to t equals 4 seconds. So the next one is x of 4 plus the integral from 4 to 2 of v of t dt. So this is calculating the position of the particle. My handwriting's really bad. And this would be in feet from the origin, and this is at time 2 seconds. Then next we have the integral from 1 to 4 of the absolute value of v of t. So what are we doing there? Because this is the integral of the absolute value, this is the total distance the particle traveled in feet from t equals 1 to 4. Okay, last one. 1 over 4 minus 1 of 1 to 4 of a of t dt. So this is the average acceleration of the particle, and this would be in feet per second squared. And this is from t equals 1 to t equals 4 seconds. So I think maybe the chart is a good thing to keep on looking back towards. Maybe summarize it in your own kind of words. Maybe my chart is too many words. It's up to you, but at some point you're going to have to know when I ask you this question, this means this, etc., etc.